Jai Hind students. In today's lecture, we'll study the topic relational calculus. This is very important topic of database management system. It runs with the code KCS 501. Okay. So first of all, we need to understand the relational calculus and then its types and how we may be able to write the queries in this relational calculus. So first of all, we have gone through the procedural query language, that is nothing but the SQL, that is commercial language, and relational algebra, that is also procedural query language. Now we are studying relational calculus, that is non-procedural query language, that tells the system what data to be retrieved, but it does not tell how to retrieve it. That is why it is known as non-procedural query language. In the procedural query language, we used to tell the system what data is to be retrieved and how it will be retrieved. But here in the non-procedural query language, listen carefully, what is the important? We are not telling the system how to retrieve the data. It means what we are doing? We are just describing the information. The way we are describing the information decides the types of relational calculus. There are two types of relational calculus, tuple and domain relational calculus, right? Okay. These are the types, right? Tuple relational calculus and domain relational calculus. In the tuple relational calculus, what we will do? We will describe the information in the form of tuple. And in domain relational calculus, we will describe the information in the form of domain, or we may say set of attributes, right? So first of all, we will take the tuple relational calculus. So it is obviously, we already discussed about the non-procedural query language. It is the non-procedural query language. In this language, we will write the query in this form. Now, what is this T and PT? So we'll write the query in this form where this T is the set of all the tuples, right? Where T is the set of all the tuples such that the predicate PT, P is true for the tuple T. So here we can properly understand this form. T is the tuple or set of the tuple. P is the predicate. If we are writing P in the bracket T, it means that predicate is true for all the T, for all the tuples which are described here, right? So here T is the tuple variable. If we are writing TA, not here we have written, but we can write the T in the angle bracket A. It denotes the value of a tuple T on attribute A. If we write T belongs to R, this is the sign we use to indicate the belongs to. So T belongs to R denotes that tuple T is in the relation R. P is the predicate, is nothing but the formula similar to the predicate calculus, right? Now, these are the formats regarding the tuple relational calculus, right? Some of the comparison operator we will use: less than, greater than, less than equal to, greater than equal to, not equal to. These operations may be used for the comparison of the values, comparison of the tuples, and these are the connectors. If we are having more than one condition, we can use those connectors, right? We will use this implication if required somewhere in the query, and two quantifiers we will use in every relational calculus, whether it is tuple, whether it is domain. So this is nothing but there exists quantifier. It means if we are writing this, it means what? There exists a tuple in T in the relation R such that the predicate Q T is true. And this is another quantifier known as for all. So here we are indicating that Q is true for all the tuples T in the relation R. So these two quantifier we will use throughout the query. We'll write in the tuple relation calculus format. So this is, I'm taking one example. Find the ID, name, department name, salary. These all are the attributes of the instructor relation. So here I have not taken that instructor relation format. So I'm telling you, instructors is a table in which there are these 4 tuples are there. Right now, what we need to find out, we need to find out the salary that is greater than $8,000. Right. So how we will write this query in the form of tuple relational calculus? Listen carefully. We have understood the format. We'll write the curly braces both sides, and inside the curly braces we'll write T. T means tuple or set of tuples. Then we will make this line, and then after that, as we need to find out all the tuples, we need to find out here ID, name, department, and salary. These 4 tuples are, these 4 attributes are the part of a single tuple in the instructor relationship. So what we will write? I'll write that T. We require whole T. So we write T belongs to which table? Instructor table. And what is the condition? Salary should be greater than 8,000. It means what we need to write? We need to use the connector. Yes, because we need to add the condition. And what is the condition for that tuple? Salary should be greater than 80,000. So by this way, we will write the query here. In the next example, we need to write the query to find the instructor ID only for the instructor who are having salary greater than 8,000. This query is similar to the previous query, but here we need not to find the whole tuple. We need to find only the instructor ID. Okay. So what we will do then, we'll make that curly braces both sides. Then we'll write the tuple T which we need to find out. We need to find out here only the instructor ID. So here we will write there exists S. S is nothing but another tuple variable we are using to show or describe the information. Here we require only the instructor ID, but this is tuple relational calculus format. So we will assign some subtuple, or we can say the tuple. So information will be described in the form of tuple only. So here we are using another tuple variable. There exists S that also belongs to instructor. And what is the condition? Instructor ID in tuple T should be equal to the instructor ID in this tuple S. And what is the condition? We will add the condition by this connector S salary. It means the tuples we are finding out, for those the salary should be greater than 80,000. So by this way, here we are representing our query with the help of 2 tuple variables. Why 2 tuple variable requires? Students, listen again. We require this one more tuple variable because we need not to find the whole tuple T. We need to find the instructor ID only. That's why we require one more tuple variable. It may be S, it may be V, and whatever you can take, right? Okay. Now we can take one example. Here we are having 6 tables. One is the branch, another one the customer, account, loan, depositor, and borrower. So this is the famous example of 4th book, right? So in this table, branch name, branch city, and asset are the attributes. In the customer table, customer name, customer street, customer city maybe is the attribute, right? Account, branch name, account number, balance is in the account relation. And loan में क्या है? We have that branch name, loan number and amount. Depositor and borrower are the relationships. We have understood the fourth example, banking example very well. So this depositor is the relationship, borrower is the relationship. What are in these? Customer name, account number, here customer name and loan number, right? So we have understood these 6 tables very well. Now we'll form the query. Like first query, find the branch name, loan number and amount for loans over $1,200. So here we, as we can see here, branch name, loan number and amount. If we see branch name, branch name, loan number and amount, all 3 attributes are required here. So we need not to take one another tuple variable here. We will take this T and then we will describe the information on this T only, because whole tuple is required. So we'll describe the information. There exists a T in the loan relation and we require this connector to connect the condition. So what is the condition? Loan should be over $1,200. So T in bracket amount, what we are writing here, the attribute. Amount is one of the attribute that should be greater than 1200. So this is what the condition. So here we have written our tuple relation calculus query with the help of only one tuple variable, because whole tuple was required. So we need not to require one another tuple variable here. Listen carefully. In this, we need to find the loan number only for the same set of query. So instead of branch name, loan number and that amount, we require only loan number, right? So here we will require 2 tuple variable. One is the T, because that what will be the actual tuple? Actual tuple will be the branch name, loan number and amount whole combination in the loan relationship. But here we require the loan number only. So to describing the information, we require one more tuple variable. So we'll start with the T. There we will require one more tuple variable. Let's suppose it is S. There exists S in loan. We can say it is a subtuple, right? Where how we will establish the relationship between this T and S. So T dot loan number, we represent here T in bracket loan number. It means the loan number in the tuple T will be equal to the loan number in tuple S or subtuple S, and we require one connector, and then S amount should be greater than 1200, right? So by this way, to describing such query, we require 2 tuple variables. Okay. Now, the next example we can take, find the name of all the customer having loan and account or both at the bank, right? So how we will write this such queries? So we find the name of all the customers. So here, having loan and account or both, right? So here we need to take all the customers who are having loan. We need to take all the customers who are having account. We need to take all the customers who are having both, right? So union will be used, right? So here, instead of union, what in relational algebra it is union, but here we can use this connector OR, right? Because we are using this OR here in the condition. Okay, how many tuple variable are required here? For this loan, for this account, right? So there exists a tuple T, original tuple, and there exists some tuple S in borrower relationship. How we will establish the relationship between these two? T, customer name, equal to S customer name, right? Or there exists U, one another tuple variable, for which relation? Depositor relationship, where T, we are establishing the relationship between these two. T customer name is equal to U customer name, where we are establishing the relationship between this T and between this U. So T customer name is equal to U customer name. In general, students found difficulty to establish this relationship. What will be written here? This tuple variable, or this tuple variable. So we need to understand, we want to establish the relationship between these two, then these two tuple variable will be required here. If we want to establish the relationship between this and this, then these two tuple variables are required on some attribute for the equality. Right? Okay. The next query is to find the name of all the customers who have a loan and account at the bank. Right? So this query and this query, what is the difference in these two? There's a difference because it requires what? Intersection. Who have a loan and account, means both. Right? So only the difference here in this query is this connector. So intersection, we are using and here as a connector. All other things will be same. We are writing there is a tuple T. We need to find out the tuple T. There exists tuple S, element of borrower, and we are making the relationship between T and S. So T customer name is equal to S customer name, and there exists U. In which relation? Borrower. Depositor. Right? And we want to establish the relationship between T and U. So T customer name is equal to U customer name. Right? The next query. Find the name of all the customer having a loan at a particular branch. Here we have taken Parallage branch. Right. So how we will write the query? We'll write T, and then there exists a tuple S, element of borrower relationship, and T customer name is equal to S customer name, and there exists U, element of loan, and we will write the condition here. U branch name is equal to the condition given, Parallage, and U loan number is equal to S loan number. So we are making the relationship between these two. Why so? Because we need to find out the loan numbers for the Parallage branch only. So we need to give the relationship between S and U. So we are writing U loan number is equal to S loan number. We have already established the relationship between T and S. Right? So by this way we can write the query here. Okay. Find the name of all the customers who have a loan at Parallage branch but no account at the branch. Right? So here we will write the query like in the similar fashion. There exists S. There is a tuple T where exists S, element of borrower, and T customer name is equal to S customer name, like similarly like that, and there exists U in the loan relation where U branch name is equal to Parallage and U loan number is equal to S loan number, exactly same as this, which I have explained to you. And the next condition, no account at any branch of the bank. So we'll write and not there exists V at the depositor, V customer name is equal to T customer name. We are making the relationship with the main tuple, right? Because we were finding out the information, we are describing the information for this only. So here we have described the information with some subtuples, and when we need to describe no account at any branch of the bank, so we are making the relationship with this V to T. We will start from there. Okay. Now the another example, find the name of all the customers having a loan of Parallage branch and the cities they live in. So we need to find out the customer city also. right? So we'll start with the T and we will describe the information. There exists a tuple S element of loan, and S branch name is equal to pairage, and there exists U element of borrower. U loan number is equal to S loan number. We are establishing the relationship between these two. And T customer name is equal to U customer name, right? And there exists V element of customer. U customer name is equal to V customer name, and T customer city is equal to V customer city. We are making the relationship in these two, and at last with this, right? So by this way we will be able to write the query. Now the next type of the relational calculus is the domain relational calculus, a non-procedural query language equivalent in the power to tuple relational calculus. So how we will write the query in domain relational calculus format? This is the general form to write the query in the domain relational calculus, right? Okay, so here what is this x1, x2 and xn, right? It represents the domain variable, right? And p represent a formula similar to the predicate calculus, right? Okay, so for the similar set of tables, we may have some examples queries here for the domain relation calculus also. Let's suppose find the branch name, loan number and amount for loans of over this. The same query we have taken for the tuple relational calculus. So here also we will write the query in the domain relation calculus format. Now format will be, what was the general format? Here we can see x1, x2, xn. Let's print the domain variables. So we need to write the domain variables here also. So one domain variable for this, one domain variable for this, and one for this. So you will take some variables B, L, A. B for this, L for this, and A for this. So three domain variable will require here, because in to describe a tuple we require three variables, because three attributes were there. So we'll write this, and after this, these all three domain variables belongs to loan relation, and what condition is only on the amount. Loan amount should be greater than this. So we are writing this domain variable A here, that should be greater than 1200, right? The next query will take, find the name of all the customer who have a loan over this, right? So here we require only the name of the customers, not whole the tuple, right? So one tuple is described in the form of multiple domain variables, right? So here we require only one domain variable. So we are taking the C. But all these domain variables, there exists B, L, A, and because we require only this C, right? Customer name only, right? So we will write only C here, but all these variables are the element of that relation, and that C is the element of borrower, and those domain variable are the element of loan, and loan number is greater than 1200, right? So by this way we can represent the domain relational calculus. In the next lecture we will continue with these slides and these differences of the domain relation calculus. For today we'll stopping here, and in the next lecture we will continue with the domain relation calculus. Thank you so much.